Okay, good afternoon. I wanted to make another video to help you all out. And I've been reviewing some work from some people, and drawings are not meeting the standard that we set. So what I'm going to do is I'm going to review this one. I've deleted all of the identifying information from this person's work, and I will go through. I may make two or three videos to go through, but I need to go through and show you because I have seen these same problems in multiple people's work. I think too many people are just jumping on the work and not trying to learn before doing, if that makes sense. So, so I'm gonna our drawings. Let's start. I'm sorry, it's gonna be a little. I may be jumping out around a little bit because there's a lot. Okay, so if I look at this, first thing I see, all right, it's not an ANSI standard. Mm, the title block is not cleaned up. There's lowercase letters. Um, I went ahead and retyped some things like company name and automatic here because nothing was coming in automatically. Somebody had gone in here and typed all of their information in, which we know we're not supposed to do. There's weird dimensions like these on angles. We don't do that. So, um, yeah, a good drawing starts from the part. So let's go back to the part and see what we have here. So first things first, let's just take a look at this part. I'm not going to judge the measurements on whatever the physical model was that was measured. Let's just go through and take a look at the part. Okay. Again, I'm seeing ISO standards, so I'm going to have to go in. First thing I do is change this thing to the ANSI drafting standard. Okay. All right. Now you see the difference in the dimensions. They read horizontally. The text is different slightly. The arrows are filled. Okay, so that is the drafting standard we're supposed to be following. All right, so that one's fully defined. I'll go ahead and drop down a few here. I've got a boss extrude. Where was this one again? Okay, that one was on the origin. Got a boss extrude. That is, sorry about this mouse, y'all. Where did they sketch this? It's right there on the end. Okay, that's good. Got a cut revolve that is underdefined and a whole lot of information in one sketch. Okay, this is not okay. All right, so feature-based modeling, we are not supposed to be lumping a bunch of stuff into a sketch. And also, we need to fully define our sketches, right? So maybe you wanted to start with that first one. Pretty easy to measure a diameter, so you could have measured the diameter and put that dimension there. And see, that's all kinds of digits which we can't even measure, but we could definitely measure to the 1.102. That's supposed to be O2. Okay. Now that thing is fully defined, that one cut, and really all these should be deleted, right? Um, you had you've got a pattern here. Okay, so you could have put this one there and then created that one and patterned it, but having all this in one sketch, not good. Okay. We've got an extruded cut here, which is just a hole. Interesting, but it doesn't look like a hole. What have we got going on there? Very interesting. Then we've got a cut there, and then we put a thread in it. Okay, again, not following the standard that we've set. Now, if I delete that, and I delete that, and delete that, chamfer, don't really have an issue with the chamfer. I have no idea what it measured, but anyway, I know this is a mumbly video, but this is the way we have to think through things. So let's see, this should have been a hole wizard. I don't think it was a quarter 20. That's what you measured out, whoever it was created this. I think it was supposed to be a 5/16 18, but let's assume that it was a quarter 20. Should not be through all. It should be a standard blind depth. Put it right there on the end. Okay, so that takes care of that. This other cut extrude down here, it's a very confusing thing. Not quite sure how you did that, to be honest. That's very odd, but we'll leave that alone. Okay, so now let's assume we've corrected the model. No material's been set. Okay, we set our material. So this is supposed to be a 6061 T6 aluminum. All right, now the material's set. Then we would say, okay, let's go check the file properties. No file properties was set. When we're supposed to be doing this for every part. So this is going to be handle. That's a very simple name. It's usually comma something else, but I'm just going to go with that for this one. Material, we link this to the material property. The weight, we can link to the material property because you sure as heck don't want to try and figure that out. All right, that's what the CAD is for. And finish, in this case, these things that have no idea. We're just going to say it's as machined. Okay. All right. So there's a decent part. Again, I didn't correct your cuts because that would be very time consuming for the video. Just know that you should have patterned and not put all that into a sketch. You should have used a linear pattern in the features. Now, let's name it. Oh, never mind. We're just going to say, just know that this is not a part number. The description should not be part of a part number. A part number is a part number. Okay, so follow that kind of protocol. Now, if we go back over here, all right, the title block. Notice nothing has changed here because this stuff was all typed in, was not supposed to be. It comes in SolidWorks with the links already built in. So this should have been a link, which you didn't have to do. It was already there. I'm just repairing it to the description. Okay. And if that's just too big, you can always change your font. Popped on my other screen. My apologies. Left justify and drag it over here. Okay. Same thing here. This should not be typed out. It should be linked to the current document to company name, which is always fun to find. Looks like they don't have it standard in here anymore. I have to add it manually first. Okay, so let's fix that. So in your sheet file, as I've shown you before, some people, anybody that's worked with me, I've shown them, you can set things like company name here. And then you just, I don't know what your company name is, but you could also set who was the draftsman, drawn by. Okay, and the drawn date is often a very important thing to put. We'll put today's date. Okay, none of that updated because somebody broke the format. Might have been easier just to go back and start over from a standard SolidWorks format, but you get to see how to repair these things. Okay. And link that to drawn by. And delete. Link this to drawn date. And if you've got this set up in your template, you never have to go through and manually do all this stuff, okay? Once it's set, and you put the stuff in the file properties and roll with it, okay? Now this has to go to the model, and you have to look for material. Okay. This again, you're going to link to the model. And this is the finish that you typed in over there. All right, see all that stuff coming in automatically is a lot easier. Now what I'd also said was tell everybody is we can get rid of this stuff. So go into the sketch tools, trim all this off. And unless you have proprietary and confidential information, I don't think you need that block. So you can delete all the rest of that. I missed a line when I trimmed. See that? So trim, now delete. Okay, now it's much cleaner and it's automatic, and that size of that can be a little smaller. Okay. Now, you got some room to work with here. This is cleaner. Oh, I didn't fix the drawing number. Edit sheet format. So you get to see this over and over. I guess that's not a bad thing. Link to property, current document, and it's just file name. First thing. Okay. All right. Again, that's not a part number, but we're not correcting all that. Do a save as, change it to the right part number, and it's done. Okay, now let's talk about this dimensioning. First things first, it's an ISO standard. So we go to our options, go to document properties, and we change that to ANSI. All right, and we dimension X, Y, and radial, right, for the most part. So that's definitely a no-no. That's definitely a no. We like to center our dimensions. When we can, we like to show diameters on the radius, or where you can see the arc, which would be here. But this view isn't lining up with this view at all. So that violates our rules for projecting. So I'm just deleting that view. All right. Now, this, I understand why we're bouncing back and forth a little bit, because you're trying to make it easier to see, but it's super messy. It's all over the place. I would be embarrassed to give this to a machinist and expect them to follow what's going on. So I don't know what to do other than delete these. If I was presenting this handle, I'd probably present it horizontally because this is a landscape drawing. If you're going to remember our rules for nesting dimensions, let's make sure you're showing hidden lines. Okay. Make sure you're using sheet scale. Well, maybe there ought to check everything, huh? And you know what? If we were to show, yeah, just delete it. I don't care. Okay. If we were to show an end view, I think that's the correct view. If we're to show the end view and then project it, we go to Drawing tab and we project. Let me check one more thing. It is third angle. Okay. So I showed the wrong end. So let me show the other end. Yes, that's okay. All right, now if your scale is bad, okay, let me check sheet scale. Properties. Okay. 1 to 5 is, we want to stay with fractions, right? Your scale is basically a fraction. A 1 to 4, a 1 to 2, a 1 to 1, a 1 to 4, and we try to stay away from the odd denominators because the multiplication becomes fun, right? So 1 to 2 seems to work. We will project an isometric. We will turn off the hidden lines. Tangent edges is a good idea to show with a font. I don't know that there are any to worry about. And if this is taking up too much space, it can have a custom scale because, why? Because we don't dimension the isometric or the pictorial, whatever you want to call that one in the corner. All right. But what we do need to see is we need to see the ends and of course the profile. So I can project this view so that we can get that hole in the end. Okay. All right. I do need to figure out how to shorten up this video, don't I? All right, so annotation, smart dimension. We can dimension the smaller diameter. If it looks like you're going to be using 3 decimal places most of the time, you can go up here and set that in your document properties. In your units, you can change the standard that it'll use most of the time to 3 decimal places. Now, if I do a whole call out, notice my leader lines are on an angle. We don't go with vertical or horizontal leader lines. There's my information for the whole call out, and I might go back and change some of the precision on that. Okay. Now, what else can I give? I can definitely go the outer diameter here, which is knurled. So 2 decimal places is plenty on a knurled surface, I would think. That's not something I would hold against a new user. And then there's some things that might be a little tougher to line up. So we might give those over here just for clarity sake. Okay. So if I slide this guy over out of the way, then let's focus on the troublemaker here. What do we dimension? Well, let's smart dimension our overall length. Let's just start with the big one. Let's size some stuff. Overall length of this turned area. We'll clean this up in a minute. And then, ooh, what baseline do we want to use? Do you want to start from this end or from that end, or does it matter? Well, what's important on your design? Is the length of this important on the design? Is the length of that, or does it not matter at all? I think in this case, it's just a handle. I don't think it's that critical. So both of those could definitely be 2 decimal places. And that thing is going to be in our way a lot, I think. Now, I've got a diameter and a diameter. What I don't have is what's going on here. Need to get what's going on there, the largest diameter there. All right. Now let's see what else we've got. Whew, I do not like showing it that way. Okay. Let's do it this way and flip the arrows. All right, so there's that one. We may be violating all kinds of rules here in a second. So there's that first one, violating the rules already. Just keep it there for the time being. Let me measure these. That's the same. That's the same. I like it. Okay, that'll make our life easier. So we can pull that dimension across here. So it's lining up across all of them. All right. So that's our diameters on the cuts. Now we need to locate the cuts. So it looks like we established this end as a baseline. But what's going to happen? Are we going to cut these grooves in the lathe with this end chucked up or with that end chucked up? I think probably with this end chucked up. So since it doesn't matter, again, very odd kind of drawing, but if you have to think about the manufacturing of it, where do you want each of these grooves to start and how wide are they? So let's get the width of this first one. That first one is 130. These all should be the same. Yep. Ooh, well, that one's different. Why is that one different? They are not all the same. Well, that is not fun. Okay. I wonder if that was by design or by error. Those are the same. Yay, that's a lot of fun right there. Okay, I get the impression that this was by error. But we are supposed to be doing a drawing of what we see. So what we'll do is we'll say 130 2 times. Somebody needs to learn how to type. All right. So that's that first one. The second one is set. The third one, we can do a 2 times on that. And get rid of this extra one. And then this last one, I'm doing this weird, right? But I'm really trying to make sure it's clear. Let's see. Can I make that clearer? That would work. At least they're grouped somewhat. All right. So we've got one at 100 thousandths, two at 125, one at 151, and one at 130. Wow. How interesting. Okay. Well, then we're going to need to tell them where each of those cuts start. Now we could do baseline dimensions. Like I said before, where is the manufacturing going to start measuring from? Okay, well, if it was important to come from this end, we'd do it. Do we need to come from this end? I don't see a reason for it. So let's start from that end and work our way across. So you can see I'm deleting stuff. It's okay. It happens a lot. Um, Baseline dimension. So let's choose this as a baseline. And we've already got the thickness of that first cut. So we just need to establish where the second cut is. And then where the third cut is. Fourth, fifth, and last. Okay. So now I don't need to dimension that shoulder unless unless it was important, which it's not. I don't need to dimension that one because this dimension plus that tells you where that ends. Okay. Wow. So there's this method that shows them where to start each cut, and there's the width of the cuts. That's one way. A little bit cleaner is what's called an ordinate dimension. And again, you establish a baseline, and we can just place from the beginning. These are the same dimensions, but significantly cleaner, okay, in their presentation. All right, so that gives you starting point for each cut. And we can come up here and we can find the width of those cuts. So two 130s, a 151, two 125s, and a 100. I think that's clear enough. Now, the determination of whether it needs to be 3 decimal places or 2 decimal places, that's an argument that you can have. It's on the lathe, 3 decimal places, which is plus or minus 5 thousandths, not hard to hold. So we can leave it that way for now. This tolerance doesn't need to be 3 decimal places. Oh, it establishes, interesting. It sets it all at 3 decimal places, doesn't it? That'd be something I need to research to see if we can modify that or if we just need to go change our standard in the system. Options, units, and drop it back down to 2. Okay. And then do our whole call out. Yep. That's sufficient for a tabbed whole call out. That's got the standard there. All right. So the only thing we have left is on this end, there's this weird little hole. I really don't understand what's going on with the depth. It's tapered somehow. How is the extrude cut tapered? Or why? There it is. There's a draft. They put a draft and an extruded cut. Not an easy thing to call out without doing it manually. So let's change that. Actually, we can just get rid of that. Because what was actually happening there on those parts that I think you're measuring is that was just a dimple placed there so that they could support it on the lathe. So We could do a really shallow hole wizard hole. And let's see, go to like, see what that gives us. Let's just set our depth at almost nothing. Because really that's what's happening. It's actually a center drill, but that'll be our best simulation of it at the moment, based on the things that you would know at this point. Okay. And we'll say this is, actually this could just be a note. If I was doing this, I would probably just make it a note, but I would say, and I'd actually get rid of everything else. So it's really just a note. I just replaced it with a note. That's what I did. That's actually sufficient. All right. Okay. So, that's passable. That's not great. It's not terrible. Somewhere in between. Could we get away with that and get our part made? Yes. Is that our goal? Yes. There's a weird chamfer here I just realized I missed. Chamfer dimensions. You choose your angle and something adjacent. And you got a neat little call out. It's a very strange chamfer. Another very strange chamfer. All right, another rule we're violating here is we've got views overlapping. So really would like to have a larger sheet to work with here, but it is what it is. All right. Okay, I'm bored you enough and I've rambled enough. I may redo this one, but I just don't know if I can make it a whole lot more efficient. Hopefully this helps you understand where you're at. Okay, drop me a message and we'll go from there. Have a good afternoon. Acre out.